Okay, so let us start. What is the first question? So Nazanin, do you want to start asking? Yes. Yes. Okay, you don't remember. Okay, hey, let me just do it. Because this is probably which level? This is level 1 problem, yes? So if 32, what did you say? Might be wrong. 32, 35, yes? This is the problem we want to solve. And this the function is f of x equals to what is that? Tangent 4 tangent x, and they have hinted you by putting this dot cosine x there, and then you are supposed to calculate f prime of pi. Okay, so as you see, this is level 1 problem, but let us see how we can solve the problem. Okay, so you tell me what to do. So this dot here indicates what to do. Yes.
That maybe if you rewrite tan x and then cosine x, we can go.
That is possible, but why we should do that? Any other ideas? Of course, I don't have access to the formula to sheet you. Which formula do you think is relevant to this problem? So what do you want to do on Thursday? So what formula? This is the product rule. And I told you that usually in the national exam they don't put this. Okay? So you need to understand that is the product rule. Yes? So of course in this case what you said is better. We can simplify. But in principle that is the product rule. Okay? So be active. So you hear what Nazanin says makes it much simpler to solve. Okay. But usually in the national exam, when they put this dot, they are indicating to you that this is the product rule. If you solve it using product rule, it will work, but it becomes longer. But if you go back to the previous knowledge of trigonometry, in principle, you can simplify and then differentiate. And might be this is the reason that they put it in the level 1 problem. They meant this. So instead of tangent, what can I write? I can write sine x over cosine x, and then you multiply it by cosine x. The good news is that this and that are cancelled. So it is nothing except for sine x. Yes? So this function in this form is a little bit more complicated, but we learn trigonometry, we use that simple knowledge of trigonometry to simplify that. And then if I want to calculate the derivative at a given number, I have to differentiate first. And this part, you have the formula sheet in front of you. I don't know how many of you remember, but for the derivative of sine x, do you remember is? Cosine x. So that is the differentiation process. And then you replace x with pi. And then you also have 4 cosine pi. And then at the very end of the formula sheet, you see the cosine of pi is -1. And this answer becomes -4. And if you want, you can also check the faucet that I am doing it right. So that is the best way to solve this problem. Yes? But if this problem, if this is not tangent x, for example, let us say this is ln of x, then this method does not work because I cannot simplify. Then I have to use the product rule. Okay? I don't solve the product rule here, might be you ask later. Okay, so that's the solution.
On the same page, we did 40.
What?
40 on the same page.
Okay. So this is a level 2 problem. So 32, 40. And that problem is the function f of x is given to you to be e to the power of x multiplied by x squared minus 2x plus 1. You are supposed to solve this equation. So they mean what is x. When they ask you to solve this equation, it means that you need to find those values of x for which this is true. Okay, so here, the first thing, what should I do here? I have to find the derivative. Yes, because here I want to find for which value of x the derivative is 0. But this is not the derivative, this is the function itself. So I have to find the derivative first. Yes, it is very natural. But for finding the derivative, what do you think I will use? Yes?
Product rule.
The product rule, because this is the function, and this is another function, and these two functions are being multiplied. So you need to understand that yourself, and then probably in the formula sheet, if you don't remember them, the product of two functions derivative is the derivative of the first one multiplied by the second one itself, plus the first one multiplied by the derivative of the second one. So that's the formula that you can read from the formula sheet. And then, I don't know, of course this is the same f, but you should give the rule of f to e to power x and give the rule of g to this one. Yes? So if I want to differentiate, and you don't need to be in a hurry, yes? You just write the derivative of the first one multiplied by the second one itself. Okay, and then plus the first one itself multiplied by the derivative of the second. Okay, by the way, in the exam, some questions are you are only required to give the final answer. So I don't care how you find them, you just write the answer. But if it is not mentioned that only answer is required, the solution should be there, okay? Okay, so then I continue. Then you need to go and check the table, but I think this is a very famous, hopefully you remember. What's the derivative?
P of x.
E to the power of x itself. This is a function whose derivative is equal to itself. I copy and paste this part. Okay, and then the derivative of this is a very simple math 3C problem. So what this becomes 2x, this becomes minus 2. Is that understandable so far? Okay, so this is the derivative. But because I want to continue and solve this equation, I recommend you to simplify it as much as you can. How can I simplify this? Because I can see that between this and that, e to the x is in common, so I factor it out. Then from the first one, this is left. From the second one, this is left. Yes? But still I can continue a little bit more because this one and that one are simplified. So finally what I get for the derivative is e to the x squared, and then I have plus 1 minus 2, which is minus 1. So this is my derivative, yes? And then I want to solve that equation, so it means that I have to put the derivative equal to 0. So f prime of x equals to 0 means what? The derivative is this simple expression. This is equal to 0. Okay, tell me, how should I continue? The reason that I'm asking you, because most of it is not what you have forgotten. So these are essential things. I mean, if you are not stressed, in principle, you should be able to answer this question. How should I continue? Anyone else? Yes?
Yes, multiplying into the brackets.
No, that's not a good idea. Because if I multiply that, I'm making the life harder for myself. So what is the point? If I multiply this in, this becomes x squared e to the x minus e to the x equals to 0. And then what? It becomes harder, okay?
Yeah, it becomes a PQ formula
No,
solution, maybe.
no, because be careful. PQ formula is only valid. So I understand probably what you say. Yes? So if I want to use PQ formula, these numbers should be constant numbers. So if, for example, if I have e to the x squared plus sine x times x plus 1 equals to 0, I cannot use ABC or PQ formula to solve this by giving the role of A to this, B to this, and C to this. Because those formulas are only valid if these are independent of your unknown x. So don't get confused. This will not work. Okay? Yes. Anyone else? Yes?
Use the zero product rule.
Zero product rule, because you say to yourself that I have two numbers, one this number, and then the other number is equal to zero. Zero is important in this case. The product of two numbers is equal to zero. This cannot happen unless at least one of them is equal to zero. So this means that either e to the x is equal to zero or x squared minus 1 is equal to 0. But do I have any solutions for this? E is 2.7 something. Whatever x is, 2.7 to that power cannot be 0. Okay, so here there are no solutions. But how many solutions I can get from here? X squared is 1, so what is x? Plus or minus? Yes, is that clear? So finally, it is always good to write the answer. So yes. Okay. Any other questions?
3147.
3147. We want to solve, yes? So if you don't mind, let me... so function h is given by this formula, and then you see the picture down there. You want to use the graph in the figure to calculate these numbers. Okay? But be careful, you are not allowed to guess. If you solve by guessing what is the equation of this red line, what is the equation of this yellow line, what is the equation of this curve, and then solve it, it is not acceptable. Okay? So let us first of all try to solve this part. So this function is given to you. You are supposed to find h prime of 2. Before even looking at the picture, I told you which formula is relevant now. So this is problem 8, page 110. Okay, so h of x is given to be f of g of x. And then what do we do? We want to calculate h prime of 2. Okay, tell me, what should I do? Even before looking at the picture, because we still don't know what we need from the picture. So we shouldn't look for something in the picture yet. I want to calculate h prime of 2. So you know, to calculate the derivative at a point, there are two steps. You have to calculate h prime of x, step number 1. Step number 2, replace x with 2. Okay? So in order to find h prime of x, if you learned your lesson so far, you realize there is one formula relevant to this. What is that rule?
Chain rule.
The chain rule. So, and then if you don't remember, you go to the formula sheet, read the chain rule, so it becomes what? The derivative of f calculated at the inner function multiplied by the derivative of the inner function. So that's the step number 1. Step number 2 is to replace x with 2. So it becomes g of 2, g prime of 2. Okay, so that is the starting point. But now I cannot continue further until I can look at the picture and find these numbers. Okay, so this one is simpler. So for finding g prime of 2, which graph do I need? I need the graph of g prime. And which graph is that?
Yellow one.
The graph is the yellow one. So I want to know what is g prime of 2. So this is point number 1. This is point number 2. I continue to intersect the yellow curve, the yellow graph, which I will intersect it here. Do you agree?
Yes.
And then I go here. So what is this number?
-4.
-4. Is that understandable for everyone? Yes or no? Yes? So this is g prime of 2, which is -4. So this number is -4. But here, this is a two-step task. Yes? First, I need to know what this number is, and then when I found that number, I have to calculate f prime of that number. So let us just do it. So what is this number? Which diagram I need? The diagram for g, because I want to calculate g of 2. So which one is g? Is the blue one. So I need to find g of 2. So this is 2. I go down. Again, the blue curve is being intersected here. And then I go horizontally again. So that is minus 4 again. Yes? So what happens? So this becomes equal to f prime of minus 4 multiplied by minus 4. So let me wait. Is that understandable, what I'm saying? Yes or no?
Yes.
Okay. But this is not finished yet because I need one piece of information here. And which graph is useful for this one? The graph of f prime, which in this case is the
Right.
red one. So but f prime at which point? At minus 4. So this is minus 1, this is minus 2, minus 3, minus 4. I come down. This is my intersection with the red line, which is the graph of f prime. Then I go horizontally. What's that number?
-3.
Minus 3. Yes? So this becomes minus 3 times minus 4. And the answer is what? 12. Yes? It's very similar to the problem we already solved. This was the easy one. The harder one is the second one. Yes? Here, another function is defined. P of x is defined to be as f of g of x to power 2. We want to calculate p prime of 1. Yes? So let me write it here. So p of x is f of g of x to the power of 2. And I want to calculate p prime of 1. Yes? Okay, what should I do? Again, the task is the same. I want to calculate p prime of 1. That I have to follow 2 steps. I have to calculate p prime of x, then I have to replace x with 1. Okay? But here, this is not exactly the standard chain rule. It is the chain rule, but the inner function, instead of being g of x, which is the standard one, is g of x to the power of 2. Okay, the way that you might think about it is call this one in your head capital G of x, for example. Okay, then it becomes the standard chain rule. Okay, so let me ask your opinion about this. So if I ask you to calculate p prime of x, this is f of g of x. It is exactly comparable to this. The only difference is that instead of having little g, I have capital G. But the formula will be exactly the same. But wherever you see little g, you put capital G. So what happens? This becomes f prime of capital G multiplied by what? G prime of x. Yes? But now, for this one, I do not have any problems. Because if I ask you what g of x is, you will tell me this is g of x to the power of 2. But I want you to tell me what is this one, okay? So g of x is g of x to the power of 2. I need g prime of x. Okay, can you help me to do that? So what is g prime of x?
2 times g of x.
No. Times, yes.
Times g prime of x.
G prime of x, yes, because why? Do you remember I told you that do you know the rule for differentiating x squared? Yes, the rule is 2x. Now, if you have u to power 2, where u is a function, any function of x, the rule is the same as if u is x, but because of the chain rule, you have to multiply by another u prime. Yes? So here, if I ask you what is g prime, in your head, you can give the role of u to this. And then what happens? It becomes 2u, which is 2g of x, but multiplied by u prime, which is g prime of x. Yes, is that clear? Okay, so let us put everything back now into the formula. So p prime of x is f prime, instead of g of x, I put g of x squared, multiplied by g prime of x, which is 2 g of x, g prime of x. So that is my derivative. Okay, now I have to replace every x with 1. So p prime of 1, f prime of g of 1 to power 2 times 2 times g of 1 times g prime of 1. Okay, so far I really don't need even to look at the picture because this is not something related to the picture. That is a generic argument. Okay, any questions so far? Okay, again, as before, I need to find three things, yes? I need to know what is g of 1. I need it here and there. I need to know what is g prime of 1. And I also need to know what is f prime at that number. Okay, so for these, I have to look at the picture. Okay, so let us start with the simple ones. So g of 1 appears 2 times. So can you tell me what is g of 1? So I refer to the picture. Which one is suitable for answering g of 1? The blue curve, because the blue curve is related to g. Yes, so what is g of 1? Can you read it yourself on the picture?
-1.
Everyone agrees? Because this is 1. I want to know g of 1, so I go to intersect the blue curve and then go horizontally. So this number is what? -1. So g of 1 is -1. This one is -1. This one is also -1. But remember, -1 is supposed to be squared. So if you don't mind, let me do one more step. So this becomes f prime. This is -1, but -1 to power 2 is 1. Multiplied by -1 times 2 is -2. So if you don't mind, let me write -2 here. 2 times, everything is being multiplied. 2 times -1 is -2. -1 to power 2 is 1. So this is f prime of 1. And then I have to multiply by g prime of 1. Yes? And then I have to calculate this and this using the picture. This one is for f prime. This one is for g prime. So I go back to the diagram. So, okay, can you tell me what is f prime of 1? This is the f prime function. F prime of 1 is here. I go up to intersect and then I go horizontally. Do you agree that is 2?
Yes.
So f prime of 1 is 2. What is g prime of 1?
-2.
-2, because here this is 1. G prime, I have to intersect with g prime, so I have to go down. And when I find the intersection, I go horizontally. So that is -2. So the first one was what? Forgot. Is 2. 2 and -2, yes? So I go back here. So it's -2. This one was 2. This one is minus. Yes, and if you multiply them, it becomes 8. Okay, so the question that you asked, I just asked, I can solve the first part because the second part, reading it from the picture, will be the same. So the function that you ask in that exercise, if you want, of course, I can solve it in full detail, but
No, I only was wondering about the chain rule thing.
okay, so I will do that. So in that example that you mentioned, this is something like this. And then we want to calculate, for example, h prime of x. And then we replace x with the given number in that problem. Okay, so okay, how can I do that? Is this the standard chain rule? It is not, because the standard chain rule is f of g of x. But this is f of something else. So that something else in your head, you can call it capital G of x. Yes, and then differentiate it as before, using the standard chain rule. So this becomes f prime of g of x multiplied by g prime of x. Okay, so this is a little bit harder than this one, so let us solve it. So g of x is this one, so I don't have any problems with that. So g of x is 1 over g of x. Okay, but the problem is to calculate this one. So how should I calculate this one? It's very similar to that function, but that function was g of x squared. First you compare that in your head with x squared. Here you have 1 over g of x. So you compare it with what?
First you take the derivative of 1 over g of x and then g prime of x times g prime of x.
Okay, so yes, might be that is right, but let me answer my question. Okay, so there, it was g of x squared. You compare that immediately with the x squared function, and then replace x with u and use the chain rule. So if I want to follow the same strategy here, so this function is comparable to what first?
1 over x.
1 over x. Okay, so this function is comparable to 1 over x. I don't know, do you remember the derivative of this? If you don't remember, you have to find it yourself. If you remember, the derivative is this one. Okay? If you don't remember, what is that one? I really recommend you to memorize them the day before the exam, especially for this one and for this one, yes? Okay, but in case you don't remember, so what you should do? So you write it x to the power of minus 1, and then take the derivative of this one, minus 1 goes down, x to the power of minus 2, and then you bring it down, it becomes this. Yes? Okay, anyway, so 1 over x, the derivative is this one. But this is not useful because this is not x, so you have to find this one. Can you tell me what is this one then? It follows the same rule as if u is the same as x. But the only thing that you have to remember is to multiply by u prime. Okay, so here if I ask you what is g prime of x, in your head you can give the rule of u to this. So the derivative becomes minus 1 over u squared multiplied by u prime. That's it. Yes, and then you are done. So the derivative is what? H prime of x is equal to f prime of 1 over g of x. Instead of capital G of x, I put this. And instead of g prime of x, I put this. So multiplied by, if you don't mind, let me multiply this by 1. Yes. Is that clear?
Yes.
So let me give you another example of this type. Yeah, because that's an important question. So not the whole part, I mean only this part, for example. So if I give you something like this, h of x equals to f of the square root of g of x. Okay, so I want to wait for you. Can you do that? Only the derivative part. Okay, let me see if you can do it. Then is of course to calculate h prime of x using the appropriate version of the chain rule. Okay, so for making sure that you really understand even the diagram, so if you don't mind, after doing that, calculate this one, okay? So which numbers are suitable here? So let us take it one, okay? Because I want to make sure that you really can read the information from the diagram as well. Again, let me repeat, you are not allowed to guess the diagrams. And don't panic if the diagrams are complicated. We don't care. We just care about the points, okay? The points of intersection. Strategy. I don't know. If I want to design, this doesn't work here. Yes. Let us just take this h prime. Because I have to think about the correct numbers, put them there so that you can read the information. But I want you to find a formula similar to this, but for that function. And by the way, you don't have to take it as G or whatever. If you are quick and you just write this for me, that's enough. Because I always do it myself in one go. You don't have to introduce G and things like that. If you are good in differentiation, you don't have to do this. This is just for your understanding. Okay, so what should I do here? Tell me. Yes? Let us follow exactly the same strategy for everyone to understand. So this one you will take what?
I'll take
Capital G. Yes? And the first step is really simple. It's just putting the formula there. But instead of little g, you have capital G. And this is not problematic at all, because then you take it off and put this back. So the only problematic part is calculating this. Okay? So what is g of x? Capital G of x, according to what I told you, is the square root of this one. This one is comparable with what formula?
square root of x.
Square root of x. Do I know the answer to this? Yes. But then I will write this in my head or in my scratch paper. So what is the formula for square root of u? It becomes the same rule, but you have to remember to multiply by an extra u prime. Okay, so then what is g prime of x then? It becomes 1 over 2 square root of u. I'm giving the role of u to this, so this becomes g of x. But then I have to multiply by u prime. It is very simple, by the way. I put it back, it's finished. So h prime of x is equal to f prime. Instead of capital G, I put that back. And then multiply it by this expression. And if you don't mind, let me multiply this here to write it more compactly. So that's it. Okay, so I hope that I could answer this. But this is an important question. So there are always a question regarding diagrams and derivatives in the national test. Okay, any other questions? Any questions regarding this? Is that understandable? Okay. Do you have any other questions? 27 on page what? Can you find this out? Okay, I can find it. Probably it is. So another question that Sami is asking, this is also important to realize that. So can you read the question for me?
Solve the equation 3 sine squared.
3
X.
sine x squared.
Yes, is equal to 5 sine x.
Okay. Of course, I will not give this to you because this needs calculator. Okay. But the starting point, I can adjust the numbers in a way that doesn't need calculator. So this is an important question. Okay. So, but some of you are tempted to simplify it by sine x. Okay. Be careful about that. Let me give you an example. So 3x squared is equal to 5x. Forget about this momentarily. I'm just describing what happens if we naively divide. Okay? So if I divide both sides by x, what happens? It becomes 3x, the right hand side becomes 5. And I find x to be 5 over 3. Is that wrong? No. That is one answer. But you are missing another answer by this method. When I ask you to solve, I don't mean just find one answer. I mean find all possible answers. And what you get is really an answer. But that is not the whole story. The reason is that when you divide both sides of an equation by a number, that number shouldn't be 0. So when you are dividing both sides by x, even though you don't say it, you are implicitly thinking that x is not 0. So this means that if x is not 0, x is 5 over 3. And that is completely okay. But you are so unlucky in this case that x equals to 0 is another solution that you are missing. Why? Because if I put x equal to 0, the left-hand side becomes 0, the right-hand side also becomes 0. So if I ask you how many solutions are there to these equations, how many solutions are there? 2. But if you solve it in that way, you find only one of them. So the correct way of solving this equation is to move this to the left and write it 3x squared minus 5x, and then factor x out. And then you say that the product of two numbers is equal to 0. Either the first number is 0 or the second number is 0. And then you see that in this method you are not missing any of them. You are just finding both of them. Is that understandable? So that is the same idea here. Okay, if you just divide by sine x and solve this one, it is not wrong, but it is not the whole story. Okay, so that is important to realize. Of course, I cannot give this to you exam because solving this. By the way, I can give it. Yes. Why? Let us do it. Because let us do it. So now you know how to do it correctly. So can you tell me? So don't divide. What you should do?
You put 5 sine x to the other side.
Yes, we move this to the other side. Yeah, I was careless a little bit. So you even in the exam you can do this without calculator. You will see why. I factor a sine x out. Yes, and then I say that this is a number, this is another number. The product of these numbers is supposed to be 0. This cannot happen unless either the first one is 0 or the second one is 0. Do you agree?
Yes.
Okay. But the second one means what? Sine x is equal to 5 over 3. So what is the solution? There is no solution. Why? Because 5 over 3 is bigger than 1. So even in this exam that we are supposed to have, I might give you this because there is no solutions. 5 over 3 is greater than 1, but you learn that. What is the maximum value that sine can attain? Is 1, the minimum value is minus 1. For the cosine, the same story, but for tangent, we do not have any limits. Tangent can be very negative or very positive, yes? So here, there are no solutions, so your duty is to just solve this equation. Okay? So sine x equals to 0. So how should I solve this equation? So the formulas for solving equations are not in the formula sheet. If you remember, I mentioned it over and over again when I was teaching. Either you have to discover them every time you want to use them in the exam, or you should memorize them. Yes? So for example, do you remember what formula is useful for this one? I probably taught you in that way, yes? If sine box is equal to k, so what are the possibilities for the box? So you should know that. What is that? For sine, you have sine inverse of k plus what? N times 360 degrees. If it is in radians, then it becomes n times 2 pi. Yes? And then there is another option if that is sine. What is the other option?
180.
180 degrees minus the same number and then plus n times 360 degrees. Okay? But this is a very special case. If you solve it in that way, that's okay. But that is a simpler, we can solve it simpler. But let me first use this. So here the box is this x, this one is your k. So x is equal to sine inverse of 0. And then you don't need the calculator for this because the famous numbers are in the table at the very end of the formula sheets. And then plus n times 360 degrees. But if you check that one, sine of which angle is 0? 0 degrees. So that is 0. Then it becomes n times 360 degrees. But there is another option for sine. It's 180 minus that number. But 180 minus 0 is 180. Plus n times 360 degrees. Yes? Of course, in this exam might be, if I don't emphasize, you can leave it like this. But it is always good to combine them if possible. So where are the endpoints of these angles? These are multiples of 360 degrees. So they are here, yes? And these are 180 plus complete multiples of the full circle, so it becomes here. Okay? So you can keep them like this, but you can combine these two into one single formula. So what that formula is?
180 degrees.
Yes, I would write 180 degrees times n. Because if n is 0, I will get this point. If n is 1, I will get that point. If n is 2, I will get this point back. So instead of using 360, if I insist to use 360 degrees, then I have to write two formulas. One for this point, one for that point. But if I am a little bit smarter, I can see that I can combine these two formulas into one single formula. Okay? Is that clear? So the important thing is that do not divide. By the way, if you divide, you only get this one and you say that there are no solutions. in which case there are infinitely many solutions. Yes? Yes? Could I answer that?
Yes.
Yeah. Okay, any other questions? Yes, please.
31, 27.
What?
31, 27.
3127. Why do you think you have problems with that? Yes? You don't remember, okay. This is a simple problem. I don't know even why they put it level 2 problem. Because you just need to solve it using parameters, yes? So problem 31, if I understood you correctly, 27, yes? So this problem has given us a function. Let me see if I'm recording, yes. It has given us a function, f of x equals to x squared plus 2x. So we have to solve the second part as well. So the first part, they have asked you to show that f prime of a is equal to 2a plus 2. Yes? If I want to show this, we just told you that, I just told you that if you want to find the derivative at a number, the first step is to take the derivative, which is 2x plus 2, and then you replace x with the given number. In this case, the number is also another parameter, a. So I replace x with a, and I am done. That's the first one. The second part is asking you to determine an equation for the tangent to the graph of the function. So we want to find an equation for a tangent. So tangent is wanted. At the point a and f of a. Yes? This is wanted. So you want to find an equation for the tangent line to this function at a point on the function with coordinates a and f of a. Yes? So that is the formula. So y minus y naught equals to k value x minus x naught. That is the formula for any straight line which passes through the points with coordinates x naught and y naught and the k value k. Yes? But you know that for the tangent, the k value is the derivative. At the point of tangency, be careful, okay? So this is the figure that you need to remember if you have a function, and if this point has x coordinate a, of course the y coordinate becomes automatically f of a, and then if I want to find an equation for the tangent line, I need the k value. The k value is nothing except f prime of a. That's very important, okay? So everything is in order. So instead of y naught, I put the y coordinate of the point of tangency, which is given to me, is f of a. But I know f of a. What is f of a? F of a is a squared plus 2a. When you say f of a, you replace x with a. So that is clear. So I would write y minus f of a, which is a squared plus 2a, is equal to the k value. K value is the derivative, which I already calculate. Yes? And then x minus x naught. Yeah, that's it. But you simplify it a little bit, yes?
What is the difference between that formula and y equals ax plus
There is no difference, but if you insist to use that, then that's a two-step task. Because if you write y equals to kx plus m, okay, this formula, you put k here, but m is missing. Then you have to find m yourself, okay? By putting the numbers here. So I need to replace y with f of a, x with a, and then after I found m, I can find m and then put them back. But if you use this formula, you can do it in one step. Okay?
How can you be sure that there exists no m?
What?
That there is no m for the tangent.
No, there is an m. Let me see, don't get confused. This formula is the same as that. Okay? So if I write it y minus y naught, I multiply k in, yes, and then I move y naught to the other side, and then it becomes plus y naught minus kx naught, yes, and this is what you see as m there, okay? But if you use that method, you have to plug k in and then use the information to find m. But here, someone has already done that for us, and this is the formula, okay? And then I just plugged them in. But this is probably not the end of the story because apparently you have to simplify this a little bit. So how should I simplify? I multiply the minus sign in. Or if you don't mind, let me just move this to the other side. So this becomes 2a plus 2 times x minus a plus a squared plus 2a. And then I will take this one and multiply it by x. And I will take this one and multiply it by minus a. And then I simplify this in one step more. I don't need to open this up. This is playing the role of my k. So this is minus 2a squared plus a squared becomes minus a squared. And this is minus 2a and 2a are gone. So that's the formula. Yes? So let me, yeah. Yes.
Yes, 32 on page 108.
Okay, so did I ask you to solve this or I excluded that?
I think you said that one. I'm not entirely sure.
Yeah, because apparently here I have two problems. First of all, I cannot see that. I can fix that with my glasses. Then I have to understand the Swedish one.
Yeah, 31 to 33 or 2.
Okay, so let us.
So, should I do this in English or?
So yeah, try. You don't need to translate word by word. I mean, if it's hard for you, another student can do it for me, and then we can try to solve this together. Okay?
So, Linus starts at the point t0.
Yes. So at point t0. So which problem is that? Problem
33.
33.
Yes.
Yes.
Yeah,
Linus starts at time t equals to 0.
his position m on the line is decided by the time ts after the equation xt equals
X. Okay. So this is the okay. X t minus what?
minus 2
To the power of 2
Yeah.
times 6 minus
t.
yes. So this is the equation that gives the location of Linus at time t seconds after the initial time starts. Yes, that is the formula. Okay, then number 1.
Where on the line does Linus
Lies at the initial time. Yeah, that's very simple. Yes, isn't it? You just put x is 0. And then you find 0 minus 2 squared and then 6 minus 0. So this is 6 and this is 4, so it becomes 24. I don't know if x is measured in meters or what. Hasn't they mentioned?
it was meters. I
Okay,
think.
so it means that it is here.
But it's the little ones that are the hard ones.
Yes, I know. This is the first one. Is that clear? So it means that using this equation, we know where Linus is at the initial time.
Yeah.
So he does not start from the origin. He starts 24 meters away from the origin.
Yeah.
Okay, and then
Then
determine
expression for
the Haseki, it means velocity of Linus. Okay? This is what I say. This is reasonable, even though this formula is also not in the formula sheet. But in principle, we also talked about velocity is equal to the derivative of x with respect to time. That's the derivative. Okay, but the derivative here is a product rule. Okay, so you have to differentiate it with respect to t, but using the product rule. Or of course you can raise it to power 2, multiply it and simplify and then differentiate. But now because we already know the product rule, let us use that. So the product rule tells me the derivative of the first one. Okay, so how should I take the derivative of this one? This you need to use the chain rule, even though this is simple. So in your head you take this to be u, then it becomes u squared. U squared is comparable to x squared. The derivative of 2x x squared is 2x, so the derivative of this becomes 2u but u prime. Okay, so I will write everything down so that you are not confused, but you can do some part of it in your head. But here on the board I will write everything, okay? So the derivative of this one, 2 goes down, and then u, which is this guy, but multiplied by derivative of this. Yes? Multiplied by the second one itself. Plus the first one itself multiplied by the derivative of the second. But the derivative of 6 is 0, the derivative of t is minus 1. T is playing the role of x. Is that understandable?
Yeah.
Okay. So this becomes what? Minus 1. And then I simplify this one more step. What is the derivative of t minus 2?
1.
Is 1. So velocity, which is also a function of time, is equal to 2 times t minus 2. This is 1, and this is 6 minus t. And then this one is plus t minus 2 squared. That's it. But I prefer to simplify it a little bit, so it doesn't hurt if I take this as a factor t minus 2 out. Then from here 2 and 6 minus t are left, and from here 1 factor of t minus 2 is left. And then I step one more step, t minus 2 multiplied by 2 times 6, 12, minus 2, 10. 2 times minus t, minus 2t plus t is minus t. That's the answer to the second. So actually this is a good question because you really don't need that much physics. But in the previous case, you need to also know the formulas for angular velocity center. Okay, the last part.
Yeah. The speed is 0 when Linus turns. At what point does this happen?
Okay, that's also very simple. Yes? So I didn't expect that this is a national exam question because it's more fairly simple. Yes? So you need to calculate where the when, if I understand, nar means yes, nar means when, yes? When the velocity of Linus is 0. Okay? So part C, I want to know at which time the velocity is 0. Okay? Okay, so I solve this equation. Instead of v of t, I put t minus 2, 10 minus t equals to 0. And this means that again the 0 product rule. The product of two numbers is 0. So either the first one is 0 or the second one is 0. The first one 0 gives you t equals to 2, or the second one gives you t equals to 10 seconds. So it means that at 2 instants of time, Linus' speed is momentarily 0. And it is possible. For example, if you throw a stone up, that stone goes up. Momentarily, the speed becomes 0, and then it returns back. Okay, so something like that.
Yeah.
So at least this was not very hard to answer right there. But the second one I have to read, and then I will do it for you later.
Yeah.
Yes.
Thanks.
Okay. Any other questions?
You do 23, 30.
23,
23, 30. Page 55.
55.
And you said you want to test us on things we should know from Math 3C. Does the national exam work the same way?
No,
They will
no,
test-
I will test it you, but not for this exam.
Oh, okay.
Because I will talk about maximum and minimum points like that in the next chapter. Yes,
But the national exam tests just everything we know.
yes, everything. Everything regarding to Math 4, not everything you know.
Not 3C.
But of course in Math 4, everything in Math 4 is the completion of what you learned in Math 3C. So in principle, Math 4 exam, except the last part. If you remember, in Math 3C, there was one chapter in trigonometry. The first part of that chapter, we have it in Math 4. The second part, which was the area rule, the sine rule, and the cosine rule, I don't think they will give you direct questions from those rules. Yes, and
I think we may have skipped that part.
okay, so you haven't lost anything for this exam and for the national exam.
Yeah.
Yes, but except for that, everything you learned there, you also have it here. You learn trigonometry, derivative, integrals. You have them here. Yes. Second question. Yes, so it means that we have to imagine a function with those properties. Okay. So we want to find a trigonometric function with the following properties. So we want to, this is 2330. So I want to find a trigonometric function f of x so that we have these properties. F of pi over 6 is what? Is 2. F of pi over 2 is 3. And f of pi is 1. Am I reading it correctly?
Yes.
Yes. So what is your opinion? I don't know, these questions are open questions, so you have to be a little bit imaginative to find a function. You see, there is no way that I can tell you think in that way to find that function. But here might be you need to think about a sine function and a cosine function. Yes. So let us say sine function. So f of x, I don't know, the general sine function might be something like this, but I don't want you to disturb yourself so much, okay? If you come up with the answer somehow by guessing, that's also okay. But it means that when I put pi over 6 there, okay, the answer is supposed to be 2. And pi over 2 is 3, pi is 1. So I don't know. I don't think there is a very good way to do it. Okay, so because that is the reason that that problem is open. I just came up with some answer. So this function works. That's why, because if I put pi over 6 here, sine of pi over 6 is 1/2. If you multiply it by 2, it becomes 1. 1 plus 1 is 2, so that's correct. If I put pi over 2 here, sine of pi over 2 is 1. Times 2 is 2. Some times 2 is 2, plus 1 is 3. And then sine of pi is 0, so that's 1. So you saw that I had a hard time to understand that, but there is nothing very specific about it.
Are these sorts of questions unreasonable for national exams or something?
Sometimes they ask these kinds of questions, but probably this is a little bit of exaggeration because you have a lot of degrees of freedom. I didn't know even I wanted to tell you that if this is not working, let me think about it later, but it worked. Yes. Yeah, don't worry about that. Okay, anyway, another question? Any questions? Because you in this problem you don't need any physics information. Yes, because they are asking about the same voltage function itself. Okay, so let us do that. That's not a, but might be, I don't know, might be this needs a calculator. When I designed the question I needed to. Okay, so this is question 2253. So this is the voltage U as a function of t given to be 20 sine of 100 pi multiplied by t plus 150. 1 over 150, sorry.
No, what question is this?
2253.
I have a different.
What?
I have
Might be I have written it wrong because my
so you 18,000 times t plus pi over 2.
So is the number that I have written here 2253? So let me write what is in your book. Okay, can you read it for me? It's what? 18,000?
18,000. No, first 20 sine
20 sine
and 18,000. And then within parentheses, t plus pi over 3.
Yes. Okay, that is the voltage given as a function of time, and then what you want to find the time when the voltage becomes 15. Yes, is that right? The same
After
number?
how long does the
Yes. So for how? Can you read it completely?
the voltage in the
No. The last question.
after how long does the voltage become 15 volts?
Okay. Okay, that's good. So it means that I want to know the time for which this is 15 volts. Yes. Okay, so this means that I put this equal to 15. Yes. And then of course it's an indication to solve this using radians. But then I told you that this is not something that I can give you because this needs calculator. Because if I divide by 20, it becomes 15 over 20. 15 over 20 is not a famous number, but it's an acceptable because less than 1. So if I divide by 5, it becomes 3 over. Okay, then what you have to do, you have to write this number is equal to sine inverse of that number plus 2n pi, because I have to write it in radians, or that number is pi minus sine inverse of 3 over 4 plus 2n pi. Of course, this really needs calculator, yes, because then what I need to do, I need to divide by 18,000 and then move pi over 3 there. I get one group of solutions from there, and then I will do the same thing here. I get another group of solutions there. But the point is that this is a meaningless question because this function this voltage can be 15 for a lot of times. Yes? Usually they ask you what is the first time that this happens. Then you have to find the lowest value for t by putting these numbers in the calculator.
But I think when it says after how long, then they mean the first time.
The first time. Yeah, might be if you can. So, yeah. But then, of course, this I cannot do it on top of my head, so you have to have a calculator available. But this is not a big problem.
I don't know what I did when I tried to solve it, but
Do it with GeoGebra, because if this comes in the national exam, this definitely will come in that part that you have access to GeoGebra, and try to use GeoGebra to solve it. And in the exam, you can say that, okay, I put this equal to 0, I get these solutions, or even you don't need to solve it, but you can describe, I solved this using GeoGebra, I got these answers, and then I found the smallest answer, and then use all parts using GeoGebra. We will train about this before the national exam, of course. Yes.
one thing, when I put cosine 2 pi, I should get 1, right?
Yes.
And then I tried putting like every number above 2, and I still got 1. Why is that? No, I put like really big numbers, like 6,000 pi, and I got 1.
Yeah, that's clear. This is something you can describe, and now I can ask you why. The cosine of 6,000 pi is also 1. But for example, cosine of 5,999 pi is minus 1. Why?
Because it's 1 pi less.
Okay, but then the important thing I told you, cosine and sine matters where is the point located on the unit circle. So when you say that I have 6,000 pi's, so you return back to the point 0, so it will give you, but if you say 5,999 pi's, you will end up here, and this becomes equal to the cosine. Yeah, that's correct. But not every big number. For example, if you put 6,000 point half and then multiplied by pi, then of course the cosine of this is not 1.
0.
No, I don't know what that is. We can calculate. What is that, by the way? Cosine of 6,000 0.5 pi's. No, don't get confused. This is super important. By the way, might be this is E-level question. No. So what is this number? 6,000.5 times pi. I don't know, in Swedish you write 6,000,5 times pi. So I want you to find the exact value of this using the table. I don't want you to tell me the number, but this is extremely simple to calculate. So you see, you are missing one point. You need to find the end point corresponding to this angle. But that is not hard, yes, is it? Because 6,000,5 pi means 6,000 pi's plus 0.5 pi extra. Yes or no? So let me ask you, where is the final point of this angle? So if you start from here, that as you have to always start from here. You go one full round, you end up here. 2 full rounds here. 6,000 pi means how many full rounds? 3,000 full rounds. You come back here, but then you have to continue because 6,000,5 pi means 6,000 pi plus 0.5 pi. This you agree? Yes? Okay, so where is the final point? This means that I start from here, go and round and round, this 6,000 pi will take me back to the original point. But then I have 0.5 pi, which means pi over 2. So it ends up there. The cosine is 0. You said 0?
Yeah.
Yes. You're right. Sorry. Yes. Is that right? So the final point is very important. By the way, there will be questions both in national exam and my exam that test your understanding about the final point. Okay, so sine, what is sine? So first you find the angle. That was the first lesson we learned, yes? You find where the angle is located, and that angle has 2 coordinates, x and y. If you are interested in sine, sine becomes what? the y coordinate, cosine becomes x coordinate, and tangent becomes y over x. So don't forget that, that's extremely important in trigonometry. Yes. So that is good you asked this question, because probably people have forgotten. Okay, any other questions? Okay, so we'll also take Math 5 lesson tomorrow if you have any other questions, okay? And if traffic happens and you are late, so come here. I can give you time. No questions? Thank you.